Hello friends, you are welcome to lecture 60 on Design for Six Sigma DFX. We have already coined this term that you need to have an X factor. So many a times on television we watch couple of serials and there they talk about X factor. What is your X factor? Similar way, think about your product and process and what is that X factor that can really make your product process more customer centric, robust, reliable and useful to the customer and the society. So we will try to deliberate upon couple of issues as a part of lecture 60. Once again, I would like to remind you that it is not the strongest, it is not the intelligent, but the one who is responsive to change will always survive. So we had discussion on DMA-DV, DMA-DOV and little bit introduction to DFX. Now I will just open the box of X and this includes say design for manufacture and assembly, design for reliability, design for maintainability, design for serviceability, design for the environment, design for life cycle cost, design for cost, testability and robustness. Now you just think that if you even miss at least one or two out of this, then you will have to experience many difficulty at the downstream stage. Once your design is released, it will go to manufacturing, planning, packaging, to customer end or the service. They will face lot of difficulty if these X are not catered right at the design stage. So DFX technically I will say that the scenario in which the products are frequently changing, the customers are becoming more and more demanding, then the scenario led to the development of the design by team, a cross-functional approach. You cannot just sit in a room as a design person and keep the manufacturing, packaging, procurement, your marketing, servicing, maintenance people out. That approach will never help you. So you need to have a cross-functional approach. So now with concurrent and simultaneous engineering approach, you try to address the various X in the design stage, and for the first time stakeholders in the design function had a voice. So stakeholders is not only the customer, your internal customers, all the departments, they are your stakeholders, because ultimately whatever you will design, finally that will say affect their own performance. Just give a thought. Suppose McDonald's ensures the home delivery, door-to-door delivery in 30 minutes. This is only possible if the moment you place the order, manufacturing of the pizza will trigger. Now a service boy, delivery boy is just waiting at the restaurant and he is not getting the packet, he is not getting the pizza and the distance he has to cover is really large, which is not synchronized while taking the order, then definitely he will not meet the stipulated target or declared target by the company. So you are failing right at the design stage. Always remember that if you look at the bottle, then what is bottleneck? It is the neck of the bottle. So bottleneck is always at the top. So the way you design your product or process, all other stakeholders in the company, they will have to face the consequences. So many a times we say that the success or failure of the project is decided right in the first meeting, directors meeting, and it is decided in the room of board of directors. So can we really address this challenge and see that we don't end up with the unsold product, rework product, refurbishing product, or just we have to throw away the product at a very low price because you have not addressed the DFX issues right at the design stage. So these are a couple of issues that we need to do through a cross-functional approach in a company by involving the various stakeholders. So these are the 9 X which are quite popular, and company they usually look for this majority of the X right at the design stage. So let us try to appreciate. So as I mentioned that there are a couple of situations which really immediately demands the attention for DFX. For example, equipment not currently available. You want to initiate the process, but the equipment is not available. It means the order is not placed at the right stage. Methods unfamiliar to the manufacturing or assembly workforce. The way you have decided the specification and design requirements, the kind of processes or the methods it demands are very much unfamiliar, and you will end up with either lot of too much of training or a very poor performance of the people. Expensive fixtures. You already have fixtures, but now your design is demanding altogether different kind of expensive fixtures. Again, this has some impact on the performance of your downstream stakeholder and calls for DFX. Similar way, you can see the need of specialized tooling, workplace redesign in order to streamline the flow of your manufacturing, limited accessibility, obsolete or hand to find parts. There is a lot of obsolescence or the parts are difficult to get. So maybe you are purchasing from the vendor. So when I interacted with couple of companies in India, they say that we purchase the equipments, machinery, aircraft from other country, and then we find lot of difficulty in getting the spare parts and components, because either this design is obsolete or these vendors now they are focusing on some new parts. Similar way, spatial manufacturing, operator skill, assembly worker skill, tolerances beyond that which can be achieved given the available equipment. You have specified the tolerances are which are not achievable with the existing equipment. So these are the issues that really calls for DFX. Now let us try to see the various DFX. One is design for manufacture and assembly. So you can consider right at the design stage, concept stage, that what kind of manufacturing processes you would be needing, and do you really have this kind of manufacturing setup or the equipments or the operator skill available or not. You can also think about error proofing, Pokayoke kind of strategy, so that you don't make the mistake while executing your production. You have designed for reliability. So we all know reliability is the ability of the equipment or the product to deliver the particular function or performance for intended function or performance for which it is manufactured. So it is the analysis of load strength relationship, for example, and design out inherent weaknesses. You use the past data, supplier history, potential failure modes, FMEA you can conduct, and you can plan for reliability improvement right at the design stage. So quality over a period of time is my reliability, ability of an item to perform a required or intended function under stated condition. So if let us say, again I will say Maruti car 4-wheeler, if it is used in the hilly area, urban area, rural area, all more or less the performance of the car should fall well within a particular prescribed range. I will not say it would be same, but it should fall within a prescribed range. It should not just say go excellent or worst. So reliability is important. You can just think the examples and you will get sensitized. Airline cost, automotive reputation, military equipment availability, safety issues, and so on. So products, they fail because of many reasons. That design inherently incapable, your items are overstressed, variation, wear out, specification, design, coding error. There could be the noise factor which is responsible, or the interaction among the subsystem may lead to the product failure. So these are a couple of reasons, and when we talk about the design for reliability, the aim is to maximize the reliability during the service life by measurement and control of manufacturing quality screening, optimize design and build process to improve intrinsic reliability, assure no systematic faults present in the product. You can do failure mode effect analysis and provide sufficient margin to meet the life requirements. So maybe you have designed a product for 10 years, but usage condition may be different. So you can at least keep a margin so that even if it is used under, say, little bit adverse condition, you will get more or less the same functioning of the product for the intended period of life. So you have design for reliability and various tools, FM EA or FMECA, there are different variants available, fault tree analysis, physical say physics of failure study, stress, strain and other phenomena you can study, finite element analysis, development testing and data analysis. The another important X in DFX is maintainability. You have given the vehicle to the customer, but over a period of time there are some maintenance requirements, and can you really reduce the downtime by focusing on, say, maintainability aspect right at the design stage. So for example, in a very simple manner, I need to change the spare wheel. So is the location of wheel is very remote, and can I fit the spare wheel, or will it be too much cumbersome? Similar way, you want to replace some of the component of the machine, what is its location, and will it really take too much time, or the downtime will be very high. So these issues you need to cater at the design stage. So maintenance time, downtime, complexity in executing maintenance are a couple of issues that can very well be addressed at the design stage. So design for maintainability, customer loyalty depends on long-term satisfaction, and it is not only delivering the product, but once the product is delivered, customer should be able to maintain it with a very little difficulty, and this is where long-term relationship comes in picture. So car that require a floor jack, I gave the example to remove the spark plugs, or a, say control harness to replace a shock absorber, do not inspire customer confidence in other aspects of the product. You just see that such a small component, and for that if you have to really use the floor jack or some other kind of say assisting equipment, then customer will lose the faith and loyalty in the product. Design for serviceability. Ideally speaking, I want a robust product, and suppose I have purchased a washing machine, then this machine should give me the service for maybe 10 years and 15 years. I would like to replace the product. Suppose I have purchased a refrigerator, and nowadays we are getting such kind of excellent products. So refrigerator, hardly I feel I have gone for any maintenance in last 15 years. So a fantastic quality, and after 15 years you may feel like, say, replacing it with the new technology, your space requirement has changed, or some 3-star, 4-star, 5-star electricity saving technology has come, or your refrigerants, they are now eco-friendly. So you can opt for a new technology, but so far the duration of 10 to 15 years is concerned, there is absolutely no need of service. Fine, this may not be possible in all the cases, but I must try to address that. Even if there is a need of service, then ability to diagnose, remove, replace, replenish or repair any component or subsystem to original specification with relative ease. So poor serviceability produces warranty cost, customer dissatisfaction, lost sales, market shares, mainly because of loss of loyalty. And serviceability, as a personnel involved in the early stage, they can give you lot of input. So many times we ignore this say down the line, say people who are actually struggling dealing with day to day service problem, and if we really say approach them, they can give a very good advice, and this can really help in designing the better product. So many companies, say let us say furniture manufacturing company, for example, I have seen they will call a summit, and in their summit they will call many small and big carpenters, and these carpenters give them lot of inputs which can help them even to manufacture modular furniture, which is now available on Amazon and many other sites, that you can order and you can just fix it and you are done. So it is only possible if you have the inputs from such a skilled people who are acting, who are working at the downstream and really dealing with the product and serviceability issues. You have designed for environment. So today we talk about sustainability, we talk about environment, and definitely I cannot ignore this component. So environmental concerns as well as post-production, transportation, consumption, maintenance and repair, and typically say economic evaluation is required both for maximum economic benefit and to estimate what the expected financial savings will be there. So environment in terms of pollution, environment in terms of say policy decision or the implications of the product in terms of safety or for the society, all these issues I need to cater. So typically when we talk about the sustainability, we talk about TBL sustainability, triple bottom line. So one is environment, other is economics, and third is your social. So we need to address these issues maybe as a broader umbrella of environment right at the design stage. Many a times say you want to opt for process modification, you want to use different chemical, you want to say launch a new product, and you have to take the permission of many government agencies in order to satisfy the environmental regulations and requirements. So these issues also need to be catered at the design stage. The another X is design for life cycle cost. So please remember that my product is not used only for a small period of time. I must see that what is the total life cycle cost. So this is the real cost of the design. So this will definitely include say cost of defects, litigations, buybacks, then distribution support, warranty, implementation cost of the employed DFX methods, and all this will add to the life cycle cost. So my product right from the design stage to the end, when it will end in terms of its life, let us say whatever cost I will incur on maintenance or maybe my services or warranty cost, all this needs to be, or environmental cost, considered right at the design stage, and this is my life cycle costing. The best approach is to go for activity based costing, is a method of estimating life cycle costing, and it is a process oriented approach, activity based costing. So ABC, the objective is to identify activities in the design life and then assign reliable cost drivers, how much cost it will say attract or extract, and the consumption intensities to the activities. So this is what we can do. Now there is another design for cost, and this is better known as design to cost. The previous one, if you see, it was life cycle cost. During the entire life cycle of my product, whatever cost I will incur in terms of activity based costing process oriented approach, I try to estimate it by assigning some cost drivers, but this is design for cost or design to cost. This is different than the previous one. So there is a need for DTC or design to cost typically when organization establish a fixed design budget in an effort to become more say fiscally responsible, or perhaps a major customer has decided what it is willing to spend. Now in this situation, you are forced. I have visited one small and medium scale enterprise, and they were manufacturing say typically say furnaces, electric furnaces. So when I talked to the operations manager and design, in a very lighter way, they said that before we even know our cost, our customers and suppliers, they are well aware of. So you just see it's a transparent world, and you cannot just set the price or budget or cost which is not acceptable to the market. So design to cost comes in two ways. One is you have fixed budget. You have a salary of 1 lakh rupees and you have to manage all your affairs. You cannot just say that let me spend 10 lakh rupees in 1 month and then I will remain hungry for next 11 months. You have to manage all your affairs in the given salary. Similar way, you have a fixed budget and you want to manage your fiscal cycle, so you have to be constrained by say this X, that is design to cost. Or on the other side, your customer is well aware of the cost and he is ready to pay only some amount, willing to pay only some amount, then again you have to be extremely conscious about inclusion of the features, requirements right at the design stage. Suppose you are using the very traditional say this mobiles, which button type mobile, then maximum say 1200 or 1300 rupees, and even you get it in 450 or 500 rupees. I have checked on the Amazon. So nobody would like to pay anything more than 500 to 1300, and you have to manage your design within this. Design for taste. This is another very important dimension, that what is my adaptability to taste requirement or testability. So testing may be an integral part of ensuring quality, and it may be demanded by the customer. So many times in such cases, design must accommodate an assemble type of production assembly process rather than rely entirely on functional taste of the finished product. So many a time say you have a product, there are sub assemblies which needs to be tested, and if this kind of testing is required rather than the fully functional product, then you really need to see that how the product can be assembled, reassembled, or it can without say dismantling, is there a location or space available for conducting some of the test. So such considerations are common with complex electromechanical equipment, including avionics and mass market consumer electronic products. Design for robustness. This is the very important X required, because nowadays products, they have to perform in different environment and they must be sensitive to the noise. I am using this particular word noise to remind you about our discussion on Taguchi, and Taguchi has given the S/N ratio, which typically says that try to maximize the signal and minimize the noise. So you have to cater for the robustness and the variability of performance by deciding the tolerances, specifications and the complexity of the features right at the design stage. So I have this particular X, that is the robustness, needs to be catered, and I must see that design should be capable of accepting parts with some amount of variability and still it can produce the desired performance or the output distribution. Just see the example of D Boulder, you might be aware, and this is a project to float a prefabricated building. You see such a gigantic building down a river to its permanent site, and this is a 42.5 meter high building with a circular cross section of 30 meters and a weight of 25,000 kilonewton. So it was built in an industrial plant, transported a considerable distance across water and subsequently put ashore and placed on the foundation. So you may just little bit do a search and think that what are the factors that might have contributed towards the robustness of this deboulder prefabricated say construction. So there are a couple of examples I have summarized just to make you better clear. Let us say manufacturing and assembly. Design for vertical assembly, well, parts are assembled in a straight down motion. GM 3.8 liter V6 engine is the example of your manufacturing and assembly. Reliability, the problem was frequent breaking of piston rings in aircraft engine. So the reliability is questionable. Remedy was optimum piston and bore dimensions established and tolerance is tightened. So engine lubrication system say revised. So this is just one example that they have revised the tolerances and they have worked on the dimensions, bore dimensions, and your reliability got improved. Maintainability, a component of an aircraft automatically wants operational team that an operating parameter such as temperature is abnormal. You see, the signal is coming and this allows maintenance to occur before damage worsens. This is maintainability. You are able to detect the problem, you can proactively act and lessen the say damage to your system. Another example may be an electric car manufacturer say publishes an accurate 7-year maintenance schedule such that owner knows upfront what is required to keep the vehicle operating safely. The simple manual can even be the example of maintainability. Serviceability, replace say soldered connector with plug-in connectors, polarize say connectors, eliminate adjustments, color code, number wire ends. So nowadays you are using different colored wires also, electric wires, in order to say identify the fault and replace a particular cable when any problem is encountered. So there are a couple of examples that we can refer about the serviceability. Environment, BMW, Volkswagen are both using DFE to study the disassembly and recycling of recovered material in automobiles. So their concern for the environment is reflected in their say design. Design for life cycle cost, Florida Department of Transportation FDOT's bridge assessment say practices is one of the example, and they maintain more than 12,000 land miles and 6,500 bridges across 8 simultaneous districts. Since 1997, FDOT, this is your Florida Department of Transportation, has implemented design for life cycle cost. Testability, the example you can refer, design for testing or design for testability consists of IC design techniques that add testability features to hardware product design. So integrated circuits, you can have this kind of feature. Robustness, you can see Sony TV made by Japan. I already explained that they are trying to produce more A-grade products by having the process is more centric towards the say targeted value. Formulation of cake mix, a little example, interesting example, you all like cake, enjoy the cake. A robust formulation, amount of sugar, flour, egg, milk provides the target taste and texture no matter which oven is used or at which say altitude. So if you have the right ingredient mixed, then even such a recipe can give you the excellent robustness even if it is cooked in a different kind of oven or altitude. Before we end, think it, what is DFX, what are the different X we have discussed, what is its relevance and criticality in designing the product or process, and explain the various X with suitable examples. Just look around you and think about various products, various features of the products, and just see that how the particular X is addressed right at the design stage. Suppose right now you are sitting on the chair. Can you analyze the chair? You have put your laptop on the table. Can you analyze the table in terms of DFX? You are watching my video on the laptop. Can you analyze the laptop? So please try to analyze couple of say products in terms of DFX and just try to tick mark in a tabular format. Select 3 products that what are the X you feel that are really addressed in what way by a particular product at the design stage. So with this you can go through this particular reference to have little bit more idea, and DFX helps to improve the quality and robustness of the product or process right at the design or concept stage. So thank you very much for your interest in learning the concept of DFX. We have talked about various kinds of X that must be addressed in a cross-functional manner by including the various stakeholders, internal and external, whether it is your manufacturing department, purchasing department, your packaging department, marketing, or maybe your supplier or customer or distributor. And if you do this, you can really develop a product which is sustainable for a long period of time, because it's a highly competitive market and will really catch the loyalty of the customers. So we will continue with couple of more topics. Till that time, keep revising, keep introspecting, keep applying. Be with me, enjoy.